A grinding wheel is a wheel composed of an abrasive compound and used for various grinding and abrasive machining operations. Such wheels are used in grinding machines. The wheels are generally made from a composite material consisting of coarse-particle aggregate pressed and bonded together by a cementing matrix to form a solid, circular shape. Various profiles and cross-sections are available depending on the intended usage for the wheel. They may also be made from a solid steel or aluminium disc with particles bonded to the surface. Today, most grinding wheels are artificial composites made with artificial aggregates, but the history of grinding wheels began with natural composite stones, such as those used for millstones. The manufacture of these wheels is a precise and tightly controlled process, due not only to the inherent safety risks of a spinning disc, but also the composition and uniformity required to prevent the disc from exploding due to the high stresses produced on rotation. Grinding wheels are consumables, although the lifespan can vary widely depending on the use case, from less than a day to many years. As the wheel cuts, it periodically releases individual grains of abrasive, typically because they grow dull and the increased drag pulls them out of the bond. Fresh grains are exposed in this wear process, which begin the next cycle. The rate of wear in this process is usually very predictable for a given application, and is necessary for good performance. Characteristics. There are 5 characteristics of a cutting wheel: material, grain size, wheel grade, grain spacing, and bond type. They are indicated by codes on the wheel's label. Abrasive grain. The abrasive aggregate is selected according to the hardness of the material being cut. Aluminum oxide, silicon carbide, ceramic, diamond, cubic boron nitride. Grinding wheels with diamond or CBN grains are called superabrasives. Grinding wheels with aluminum oxide, silicon carbide, or ceramic grains are called conventional abrasives. Grain size, from 8 to 1200, determines the average physical size of the abrasive grains in the wheel. A larger grain will cut freely, allowing fast cutting but poor surface finish. Ultrafine grain sizes are for precision finish work. Wheel grade, from A to Z, determines how tightly the bond holds the abrasive. A to H for softer structure, I to P for moderately hard structure, and Q to Z for hard structure. Grade affects almost all considerations of grinding, such as wheel speed, coolant flow, maximum and minimum feed rates, and grinding depth. Grain spacing a structure from 1 to 16. Density is the ratio of bond and abrasive to air space. A less dense wheel will cut freely, and has a large effect on surface finish. It is also able to take a deeper or wider cut with less coolant, as the chip clearance on the wheel is greater. Wheel bond. How the wheel holds the abrasives affects finish, coolant, and maximum wheel speed. Types. Straight wheel. To the right is an image of a straight wheel. These are by far the most common style of wheel and can be found on bench or pedestal grinders. They are used on the periphery only and therefore produce a slightly concave surface on the part. This can be used to advantage on many tools such as chisels. Straight wheels are generally used for cylindrical, centerless, and surface grinding operations. Wheels of this form vary greatly in size, the diameter and width of face naturally depending upon the class of work for which is used and the size and power of the grinding machine. Cylinder wheel. Ring cylinder wheels provide a long, wide surface with no center mounting support. They can be very large, up to 12 inches in width. They are used only in vertical or horizontal spindle grinders. Cylinder wheel ring is used for producing flat surfaces, the grinding being done with the end face of the wheel. Tapered wheel. a straight wheel that tapers outward towards the center of the wheel. This arrangement is stronger than straight wheels and can accept high lateral loads. Tapered face straight wheel is primarily used for grinding thread, gear teeth, etc. Straight cup wheels are an alternative to cup wheels in tool and cutter grinders, where having an additional radial grinding surface is beneficial. Dish cup, a very shallow cup-style grinding wheel. The thinness allows grinding in slots and crevice. It is used primarily in cutter grinding and jig grinding. Saucer wheel, a special grinding profile that is used to grind milling cutters and twist drills. It is most common in non-machining areas, as saw filers use saucer wheels in the maintenance of saw blades. Diamond wheels are grinding wheels with industrial diamonds bonded to the periphery. They are used for grinding extremely hard materials such as carbide cutting tips, gemstones, or concrete. The saw pictured to the right is a slitting saw and is designed for slicing hard materials, typically gemstones. Mounted points are small grinding wheels bonded onto a mandrel. Diamond-mounted points are tiny diamond rasps for use in a jig grinder doing profiling work in hard material. Resin and vitrified bonded mounted points with conventional grains are used for deburring applications, especially in the foundry industry. Cut-off wheels, also known as parting wheels, are self-sharpening wheels that are thin in width and often have radial fibers reinforcing them. They are often used in the construction industry for cutting reinforcement bars, protruding bolts, or anything that needs quick removal or trimming. Most handymen would recognize an angle grinder and the discs they use. To use the grinding wheel, it must first be clamped to the grinding machine. The wheel type fit freely on the supporting arbors, the necessary clamping force to transfer the rotary motion being applied to the wheel's side by identically sized flanges. The paper blotter shown in the images is intended to distribute this clamping force evenly across the wheel's surface. Dressing grinding wheels are self-sharpening to a small degree. For optimal use, they may be dressed and trued by the use of wheeler grinding. Dressing the wheel refers to removing the current layer of abrasive, so that a fresh and sharp surface is exposed to the work surface. Truing the wheel makes the grinding surface parallel to the grinding table or other reference plane, so that the entire grinding wheel is even and produces an accurate surface.